Today, we'll start with the loop statements. So, in the previous class, we studied like the conditional statements we studied, that is if statement, and the multi-way branching statement, that is a case is it. Then we studied how to use the case statement as I mentioned in the earlier class. So if you need to ignore the value of x, or if you need to ignore the value of z, then you have to use the case x or case z. Especially this can be used in the state machines to encode the states, or as I said in our lab, if you are writing the program for priority encoder, you can see the truth table, the truth table can be incorporated in the program here. See here, the 4-P1XX, the straight, the direct the truth table values you can write, especially for the priority encoder. So this is the hint for you to write the priority encoder using case X, even for case Z also. Next, we'll go for the next set of the conditional statement, that is for behavioral model, it's loop statement. So here there are four different types of loop statements are there in Verilog HDL. So they are while statement, for statement, repeat statement, and a forever statement. So as you know, in your C programming, you already studied the while statement and the for statement in your C program. Now you might have studied the while and for, but this is very new for you, the repeat and the forever. But you can think this repeat and the forever maximum mostly we will use in the test bench program actually. The while for we will use in our program, even test bench also you can use. Now here, the syntax for each and every the loop statement is similar to C programming. Now we need to know this all four loop statements can appear only inside an initial or always block. Sometimes the loops may contain the delay expression also. Let us see the first. So what is the while loop? So here the keyword is a while actually. The keyword is while. This will be used to specify in the loop. Normally how the while statement will execute? The while statement will execute until the while expression is not true. It will check. Then only it will execute. So but if the loop is entered, then while expression is not, when the while expression is not true, then the loop is not executed at all. So if the expression is true, the while loop will execute. If the expression is not true, then the loop will not execute at all. Now, any logical expressions can be specified in these operators in the while loop. Let us see if sometimes if you are having the multiple statements inside the while loop, then are also will be executed in the loop. They must be grouped typically like using the begin and the end. As same, you know that the if statement or the case statement, we may use the begin and the end, even for initial also and the always also. So when we use this begin and end, if you're having more than one statement, then you need to use the begin and the end. Let us see what is the syntax for while statement. See, the syntax is this. While is a keyword followed by the condition. So this is the condition which are going to use. It's an identifier. Then begin. This is optional one actually. If you're having group of statements here, this one. If you're having the group of statements, then you need to use a begin end. So now let us see what is the example of this. Okay. Now here the simple example specifies the integer I. While integer less than x, this is nothing but your condition in the while is a keyword. So now begin I equal to I plus 1, z is equal to I multiplied with z and end. Now how this will execute? Well, the I less than x, if the condition is true, then these statements will execute. But if the condition fails, it will come out from the while loop. So how it will be? Let us say here how you will get the output for this. Let us consider how it will get. So before that, you have to assume I will take, let me take example, this example only. Let me take example here. I initialize to 0 first. I is equal to 0. Initialize I equal to 0. Then I'll make x is equal to 3. Example. This is what I'll say. X is nothing but your input. Assume the x is nothing but your input. X is equal to 3. Now what has happened? It is goes into while statement. That is what? While I is less than. See, I is nothing but we initialized. Okay. I less than 3. X is 3. Now let us go for the begin statement. It has to increment like I is equal to. So what I will do, let me create a truth table here. There is a statements here. I'm not going to write these statements because already is there. I is equal to I plus 1. Then Z is equal to I multiply with Z. Then end. Now what I will do, let me put here I, then I'll put something like here Z value because my result is Z only. So I'll put Z. Okay. Now let's say first I equal to 0. So initialize to I. This is the I actually. Now what is the new value of I? This is new value of I can say. This is initial. Okay. This is will be your Z value. Now I is initialized to 0. I less than 3. Yes. 0 is less than 3. If the 0 is less than 3, the condition is true. Then I will be the new I will be what? 0 plus 1. The I will become as 1. When the I becomes 1, then what is Z? 0 plus I1 is equal to 1, right? Now, what is Z value still is not given. You have to assume again here, I will say, I will make Z is 0. Initialization. Just I did. Now, what is the Z value I will get? I is how much? Because it is a blocking statement. You know that. So, this I will be updated here. So, it is 1. 1 into Z is 0. So, I will get Z equal to 0. So sorry, I should not keep z as 0 because of multiplication. I'll keep z as 1. Now if z is 1, so what is that? I1 into 1, I will get as 1. Now you would say again, what will happen? The I is already incremented to 1. Yes? I is 1 actually. Now here it will check. I is 1. 1 is less than 3. Yes, it is true. If it is true, again, what is the new value of I? I equal to I plus 1. 1 plus 1 is 2 I will get. Then what is Z? The I value here is 2. Okay. 2 into Z. What is the previous value of Z till now? So 2 into 1 is nothing but 2. So now again, next. Again, next, you can see here. See here, next, I values increment, new values 2 I got. So the new value is now the previously, what was that? Z is equal to 6 I got. Next, the I will be incremented to 3 actually. So again, the 3 is less than 3. Yes, the condition gets failed. Once the condition gets failed, what will happen? So it will exit from the loop. So totally, I will get that Z value is 6. Now you can say, what is this? Actually, this program indicates now. Initially, I said X is equal to 3. So this program is nothing but simple. I can say this indicate what? This program actually. Is there any answer? What is the program of this while statement? This is nothing but it's a factorial. So I can say 3 factorial. What is the factorial of 3? It is 6. So this is the condition or the statements you have to write. Even if you take 4 factorial, means your x. Your x is nothing but input. Find the factorial of x. So if I take 4 factorial, x is 4 in the sense automatic what will happen again. Sorry, not this. If x is 4, what will happen? Again, this statement will come over. I is become as 3. So 3 plus 1, the new value will become as 4. Next, what is it? So it is 4. 4 into previous value 6. Then this will be 24. I can say the factorial of 4 is 24 is the result. This is the one simple example here we shown. Next, one more. The illustration, the example. So now increment the count from 0 to 127. Exit at the count 128. Display the count variable. Now for this we need to write how we will write define the integer as count, the initial begin, initialize the count value is equal to 0. Okay, once it is initialized, then what we'll do while. So see, if we are using the while statement inside the initial, you see here, earlier we used inside the nothing, we are not shown anything, right? So now while count is less than 128 means first it will execute the loop till the count is 127 only, but it will exit at count as 128. See here begin, we need to display the count value. That is what they specified. Display the count variable. So dollar display within the double quote count is equal to percentage D. You are going to display in terms of decimal numbers. So comma count. This will be printed. Then count is equal to count plus 1. It is in the while statement. See, this is the while statement actually. Count is count plus 1. And now first initially count will be 0. 0 is less than 128. Yes, it is true. Automatically it will display the count is equal to 0. Next count will be incremented. Count 0 plus 1. Count is 1. Next 1 is less than 128. Yes. Then count is 1. It will give. Then 1 plus 1 2. Again 2 is less than 128. Yes, it is true. Again the count will be 2. It will display. Same like this it will display. Once the count is reaches 127. Example, if the count reaches 127. Then 127 plus 128. The count will be 128. When it goes to the while statement, 128 is less than 128. No, the condition gets failed. So automatically it will exit at count 128. So this is what we can say. So automatically it will count or it will display up to 127 only. It will display. The second illustration we can see. So we need to find the first bit with a value 1 in a flag. So you know that like this is the flag. Assume flag register. You might have studied. So now in this flag register, find the first bit with the value 1. So many values are there. You need to find when you are getting the first bit of 1, the value of 1 in a flag. So for that, this is a simple example. Here first we return define. See what is this? This is nothing but a compiler directive. You might have remember. So this is so apostrophe you have to use the compiler directives. You have to use this one. That one tick mark, that is one dash define true. So we are defining the true means value is 1. Next we are defining the false means 0. Next we are going for register. It's a flag register. It is a 15:0. So what I will do in the sense, this is 15. I will make this is 15. This is 0. So in between you can think, okay, this is the 15:0. Now integer is I. So now just the integer will be used for to keep count, because we need to find the first bit with value 1, because from here we need to check where exactly is 1 actually. So now what we will do in the sense, now we need to load the value of flag. See, register continue, the register variable is continue. Next initial begin. This is nothing but your flag register value. See this flag register value with the 16 bit. So how it will be in the sense, see 15, this is your 14 bit, 13 bit like this. See the 15 bit, or let me draw here. Okay, 15, 14 bit, 13 bit, 12th bit, 11, 10, 9, it will go like this, then 1, 0. So automatically what will happen here, it will be 0 because 16 bit, again this is also 0, this is 1, this is 0, then rest of all are zeros only. Right? So this is nothing but 15 position, this is your 14 position. This is the 13th position. You see. Now we need to check as the value is stored in a flag register. Value is here actually. So now we have to check find the first bit of value 1. Where exactly actually we need to find in this. So first initialize I is equal to 0. Then continue is equal to, see here, we are calling the comparator dash true. If I write like this, what is the meaning of that? Means the continue is equal to 1. That is the meaning of that. Okay, continue is equal to dash true we said. So that meaning is continue is equal to 1. Now the continue is equal to 1 in the sum now while I, first the I is equal to 0 because already we initialized I is 0. 0 is less than 16 and you see this is the not a logical and it is a conditional and actually in the relational operator it's a double ampersand we will use. Then continue. The continue value is true. It is always 1 actually. If both are true, then only your while statement will get executed. That is what I said here. The multiple conditions using operators. So here, if I use a multiple condition, all the statement has to satisfy. Then only your while loop statement will get executed. So here, while I less than 0, yes, 0 is less than 16, yes, it is true. Then and continue, that also it is, the continue is equal to 1, yes, that is also is 1. Both are, it's nothing but satisfy, then we'll go for the begin if flag of I. What is I value? It is 0. That is, this is nothing but a flag. Whatever we have shown, this is nothing but a flag. Right? This is the flag 0. This is the flag 1. You keep on like this, will come. Now, if flag of 0, first check, means if flag of 0 is equal to 1, that is the meaning of that. So, this is nothing but what? It is flag of 0, it's equal to 1. That is the meaning of this condition. So if it is 1, then it will enter to the begin statement, display, encounter a true bit at element number. Better we have to check whether it is 1. First we will check whether it is 1 in this flag of 0. No, it is not a 1. Automatically what will happen? The continue will become as false. Yes, the continue is equal to false. See, when this will not execute. Why? Because your flag of 0 is not 1. So it will come out from the if statement, then it will increment the I value. I value will become a 0 plus 1, 1. I is 1 now. This will be 1. So I is less than 16. 1 is less than 16. Yes. And the continue also is 1. Again, it will come over there. Flag of 1. Flag of 1 is 1. Here, see, the flag of 1 also is not 1. Again, the condition is failed. It will enter. So like this, keep on. The I will be get incremented. Now, once you get the I value is equal to 13. See example. So when it go to here, 13 is less than 16. Yes, the 13 is less than 16 and continues 1. Then it will come to here if flag of 13. See here, this is the flag of 13. Yes, the value is 1. So if that is 1, then automatically enter in this it will display encountered a true bit at element number. What is D? D is nothing but 30. That is the meaning of element number 13. That is the value of I. The I is nothing but what? It is 13. That will be displayed. So then continue will become as 0. Once it's identified, then continue will be dash false. What is the false value here? It is 0. So automatically when it comes 0, then what will happen? So it will go to again while loop. Then I will be incremented now again because after end come to increment 13 plus 1, 14 it will go. Now we go over there. 14 is less than 16. Yes, that is true. But under here the continue. What is the continue value is now present? Value is 0. So both are not satisfying. So what will happen? It will exit from the loop. That is the output we'll get. So this is how it has been written. Next, let us go for the for loop. It is one of the very common the for loop which you used in your C program. Same like that only here you have to use. The keyword is for keyword FOR. That is the only we'll use for the loop. The for loop contains totally 3 parts normally. So the 3 parts are, one is the initial condition. Next, we need to check to see if the termination condition is true, then a procedural assignment to change value of control variable. So that is what. So you can see in your C program, I hope you can write in your C program actually how the for statement will be there. Normally you can remember that For will be there like I will be is equal to 0, then you'll put comma, then I is less than or I plus 1, then I less than I plus 1, then I is equal to I plus 1, or I is less than around some value 2, example. Okay, I less than 2, then I is equal to I plus 1. So this is the thing you might have written in a C program. See here, first initial condition will be there. Next, whether you need to check the termination condition is true or not. Next, what will happen? Automatically the increment will be there. Now, same kind of the C program only we are going to write here. The initialization condition and the incremental procedure assignments are included in the for loop and do not need to be specified separately. So everything will come inside the for loop only. Now you can see the for loop will provide a more compact loop structure than the while loop. Because however, that the while loop is more general purpose than the for loop, but the for loop cannot be used in place of the while loop in all the situations. Now we can see the syntax. The for loop syntax will be like this. For is a keyword followed by lower index value, then upper index value, then step means increment, then begin, then end the here. If you are having any multiple statements, then begin end will come. Now let us see the example. Same example which is shown previous in the while, the same set of example only we are showing even here also. Now see, integer count initial for statement, right? Count is equal to 0, count less than 128, count is equal to count plus 1. Now it is very simple. What will happen? You need to display the count value, like it will display as per this what count will be 0. Yes, the 0 is less than 128. Yes, condition is true. Then count, what will happen? The count will be displayed as 0. Next count will be 1, count will be 2, count will be 3. Keep on, the count will be incremented. Now once you receive the count is equal to 127 plus 1, 128, then 128 less than 128, the condition fails, then automatically it is stopped. Same, the one more example you see here, for I equal to 0, I less than or equal to 2, I equal to I plus 1. See, this is what? Same, for loop, right? I equal to 0. Begin, if temp of I is equal to 1. Begin, result equal to result into 2. What is this operator actually? This operator is nothing but 2 double star I. Means it is nothing but a 2 to the power I. Okay, this is nothing but 2 to the power I and the instant. Now you need to see what is this program actually. It is written. Okay, so let us write what is this actually. First, see here I equal to 0. Okay, I is equal to 0. What I need to do? This is I value. Then I need to go for the result. Okay, fine. See here I is 0. I is less than or equal to 2. I equal to I plus 1. Okay, now first temp of I equal to 0, initialize. First I equal to 0 only. So it is whether the value. So simple, what I will do, what is I? We need to know first. Correct? So I will take I is equal to something. What I will do, let me take example. I is equal to 1010. Example. I is equal to 1010. Now, simple example I'm saying, okay? Not I, sorry, this is not I am going to take this is temp, okay? This is, I called as temp. Temp is equal to 1010. Now, you'll see the portion. This is nothing but 0. This is 1, this is 2, this is 3. Index position. Now you see, if temp of 0, I first 0, temp of 0 is 1, see this one. It is 1? No, it is not 1 actually. What happened? It will not execute this loop, it will come out from the loop. Okay. Next again, what will happen? I will be incremented. We'll check. I equal 0 plus 1, I is 1. Again, 1 is less than or equal to 2. Yes, 1 is less than or equal to 2. I will take this is instead of 2, I will make 3. Example. Okay. So 1. Now temp of 1 is equal to 1. This is 1. Yes, temp of 1 is 1 only. So when the temp of 1 is equal to 1, what will happen automatically here? Result equal to result. So now you should think what is the result first. you have to initialize result is 0. You have to make the result is initialize 0 actually. So the new result will be what? 0 plus 2 to the power I value is 1. Then this will be 2, right? I value is what? Now I is 1 actually. Now you can see I will be incremented to 2. When the I is incremented to 2, what will happen? 2 is less than or equal to 3. I am took this value as 3 actually. So 2 is less than or equal to 3. Yes, it is condition satisfied. Go to begin statement. If temp of 2 temp of 2 is equal to 1. See here, temp of 2 is equal to 1. No, it will remain same only then. It won't do any operation, remain same. Next, I will be incremented to 3. 3 is less than or equal to 3. Yes. Then temp of 3 is 1. Yes, see, temp of 3 also is 1 only. Okay, then we come over here, result. What is the previous result is 2. 2 plus 2 to the power I value is 3, then will be 2 plus 8, this will be 10. See, this will be my result. I will be again incremented as what? 3. 3 plus 1, 4. Now I will become as 4. Now again it will check here. 4 is less than or equal to 3. No, it will exit from the loop. Now your result, the main result is 10 actually. So now what is this program actually? This program is nothing but my given input is 1010. I got the output as 10. So I can say this is nothing but binary to decimal. This is nothing but a binary to decimal. Next example you see for loop. The for loop will be used to initialize an array or a memory. So now the for loop also can be used for the arrays as well as for memory also. Now let us initialize the array of elements. Let us initialize. So once you are initializing, like define, this is, we are going to define the max underscore states is 32. That is the maximum number of states is 32. Next integer, the state 0 colon dash max states minus 1. What is this meaning is, it is an integer array states with the element 0 to 31. The states we are having because integer state 0 colon, what is this max states value is 32. 32 minus 1. As you know, there is a difference between 0 colon 31 state and state 0 colon 31. This is already we studied. Don't get the confusion. There is a difference. 0 colon 31 state in the sense the state has 32 bit wide. Okay. If I'm going the state, then 0 colon 31, then it has element array of the element as 31. This is a single dimensional array. It's like this. It's a single dimensional array. It has 31 elements. 0, 1, 2, up to 31. This is the meaning of that. Don't get the confusion. Now, integer is I. Now, let us go for the initial. Now, let us go for begin. For I equal to 0, I less than 32, I is equal to I plus 2. Means, you are having a memory location. With the memory locations are, this is the memory location. Example, you consider like this. This is the memory location. Okay, this is the memory location. What I'm going to say now here, this is 0, this is 1, this is 2, this is 3, next is 4, here is 6, here is 8, then like that, finally it comes 31. See here. Initialize all even locations with 0. See, that is the meaning. I is equal to 0, I less than 32, I equal to I plus 1 means here I will be 0 first. I will be 0. So what I am doing, the state of I is equal to 0. See, these all are the inside whatever thing are there, those things are state. Okay. Now this is the state actually. Which one? This is state of 0, state of 1, state of 2, state of like this. Now I is 0. I is 0 means state of 0. State of 0 is 0. See, let me give. It is 0. Next, what will happen? 0, already I will be equal to 0 plus 2. Then I will be 2. 2 is less than 32. Yes. Then again state of 2 is 0. See, state of 2. next is state of 4, next is state of 6, state of 8. Like this, all the even locations we are filling with zeros. This is 31, this is 30, right? This is 30 in the sense, even 30th position also 0. Now next you see the one more for loop we are written, I equal to 1. See, because here I equal to 0, 0 plus 2, even location I get. For odd location, you have to initially I is equal to 1. So I plus 2. So automatically what will happen? It will become as odd locations like 1, 2, 3, everything will come. State of 5 means state of 1, state of 3, state of 5, everything is 1, 1. So that will be like this 1, even this also 1, this is 1, this is 1. So this is nothing but simple, it's a memory of array. See, we are initializing the value. This is example. Next loop is repeat loop. See, this is the one of the interesting loops. Repeat loop. The keyword, the repeat, is used for the loop. The repeat constructs, executes the loop a fixed number of times. See, this is very important. The repeat in the sense, just you know the word meaning of repeat. For the fixed number of times, it will execute the loop. It cannot be used to loop on a general logical expression. It's like a while expression. In the while expression, we'll write no while a less than 2 or I is less than x. Like that, we cannot write for a repeat. It is not possible. So it cannot be used. A repeat construct must contain a numbers which can be a constant or a variable or a signal value only. However, if the number is variable, say example, if the number is a variable or a signal value, then it will be evaluated only when the loop starts and not during the loop execution. Let us see the syntax first. Repeat, say as I said, repeat is a keyword followed by expression. Here in this expression, we won't have like I less than x, a less than 2, that kind of things won't come. Only constant, the number constant or any one variable or a signal value only. There is no expressions, logical expressions. Then begin, then end. This is normal as you know. Now let us see the example. The first example which shows 100 clock pulse we need to generate. We need to generate a 100 clock pulse. Like this, we need to generate 100 clock pulse. We have to generate. That's why I said something. I think you hope remember. If you want like this will be executes for a fixed number of times. You see, only exactly I need to generate a 100 clock pulse. How it can be generated 100 clock pulse? So first the register is a clock. Okay, initial. This will be used in a test bench. Keep it in the mind, or in a program also. So test bench only actually. Register clock initial begin, initialize clock is equal to 0. Now you see here the written repeat within the bracket 100. See, this is the number actually. It's a constant number we specify. So for 100 times, that is a repeat. 100 means what? So after the unit rate statement here, hash 5 clock is equal to not clock end. What is the meaning? First the clock is initialized to 0. So the clock is initially to 0 in the sense. So first is 0. Up to what time? 0 to 5. Next, after 5 clock, what will happen? Get invert. So I can say it will become as 1. That is 10. It become as 1. Next, what I will repeat for 100 times like that. So your time period is nothing but how much? The time period is 10 actually. So it will generate for 1 clock pulse for 10. So like this, it will generate 100. So it will run up to 1000 delay, it will generate. This example. Next you see, if you want to use a counter, see 32 bit counter. Integer I will say repeat of 32 because this counter has to count 32. What is the meaning of counter? As you know, the counter will count the number of clock pulses. So now 32 bit counter in the sense, we need to generate a 32 clock pulse. That is the meaning of that. So now we begin hash 100 I is equal to I plus 1. First see integer I, what will happen? Initially I is b is equal to 0 only, 0 plus 1, I will be 1. For every 100, 100 for first 100, the I will be 0 because we initialize already in the 0 delay, I value is 0. This next for 100, I value will become as 1. Next 200 because every 100, next what will happen? I plus 1, 2 will become. Next for 300, I will become as 3. So it will repeat for 32. The count will go like this 4, 5, 6, it will go up to number 32. So then it will get stopped. So this is the function or the usage of a repeat statement, which will be used more useful in your test benches when you're going to generate the fixed number of cycles. Then let us see the another example. Increment and display count from 0 to 127 using the repeat statement. So yeah, the previously I shown the same thing only. Integer, counter, initial, begin, count is equal to 0, then repeat 128. Repeat of 128, begin, we need to display. Count is equal to 0. First the count will be 0, then count will become as 0 plus 1. See, now there is a loop here, you may say. Repeat, see, this is the loop actually. Right? Begin, repeat, begin, end. See, these are the statements. Count plus 1. Like this up to 128 count, in the sense not 120, 0 to 127. Same like even here also, it will count to what? 0 to 31, it will count. Next example you see. Here this example shows how to model a data buffer that latches data at positive edge of clock for the next 8 cycles after it receives a data start signal. Now what you need to do? You need to model a data buffer. That is example I say this is a data buffer. Data buffer, okay? This is one buffer, data buffer. So that latches the data at a positive edge. See, this is the positive edge, I say clock. It latches the data in the sense I can say it is D flip. Simple, I'm saying. It latches the data at the positive edge of the clock for next 8 cycles after it receives a data start signals. So the data will be latched for 8 clock cycle for the next 8 cycles. Then after that it receives a data start signal next after 8 cycle. Then we need to write how it can be written. See, module data buffer data start. There is a signal called data start because it has to start, right? So as soon as 8 clock pulse receives, then the data has to start. That is the meaning. So data start, data clock. Now I'm giving the parameter, the cycle is equal to 8. That is the parameter value, the cycle is 8 I given because of here we used 8 clock cycle. So now that is meaning is here what I am trying to do in the sense just is the data buffer module after it receives a data start signal, read the data for next 8 cycles. That is what meaning here. So first input data start, the input because this is the input, right? Data start. Next input your data is 16-bit data example. Then input is clock. Then I'm going to register 16-bit register buffer 0:7. What is this meaning actually? This is nothing but simple. I can say the buffer has how many? 0 to 7, 8 elements. See, this is what I can say. Buffer has 8 elements. 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. This is 0. This is 7. Now, each and every data is a 8-bit. That is the meaning of this, right? This meaning register 15:0 is a register. The buffer it's a array. Buffer is an array of 8 elements. The each element is 16-bit. Now integer I always passage clock begin. If data underscore start means the data signal is true means data start is equal to 1. If the data start is equal to 1 if I get because that is the input, right? If it is 1 then I will be 0. Repeat cycle. What is the cycle here? See, already given parameter. Cycle is nothing but how much? The cycle is 8. Repeat for 8. So I is equal to 0. Repeat for 8. You see that next begin. Okay, repeat at positive edge because in the every positive edge during the positive edge, the buffer of I. What is the I value? Is 0. Buffer of 0 will be data. See this one. Buffer of 0 will be data. So this data will be latched. Now what will happen? It will wait for till the next to positive edge to latch the data. Again, what will happen? I will become 0 plus 1. I will be 1 now. Again, it will check whether the data signal is true. No. So what will happen here? This I is 1. Then again, it will go to repeat. See, it is repeat only, right? I is equal to 1. Buffer of 1 is data. Yes. So buffer of 1. Even here also latched. Next I will become as 2. Even this also will be latched. Like this, each and every time the data will be latched. Now when you will get I equal to 8. When you get I equal to 8, what will happen? It will come out. Then it will start the data start. So this is what how it will work. So for the 8 next as next data start will get next again I will become as 0. So for 7 cycles, right, for next 0 to 7 the data will be latched. So again the I will become as 0 once the data is starts. So this is the example. Now the one more, the next loop statement is nothing but the forever loop. You see, forever loop. Forever loop. This is one of the interesting loop. Actually, the key word, the forever, is used to express the loop. Now, the loop will does not contain any expression and it executes forever until the dollar finish task is encoded in the test bench. So now you can see there is a difference, little bit difference between where repeat as well as for more or less almost equal only actually. So, but is because the repeat statement also does not contain any expression, even the forever also will not contain any expression and execute forever until the dollar finish. Even there actually it will execute for a constant numbers because repeat of 28 if I give up to 28 only it will run, but the forever is indefinite. So you must to give the dollar finish command to stop your simulation. So now the loop is equivalent to while loop actually. So with an expression that always evaluates to true, like the while of 1. So now let us see the forever loop can be excited by use of the disable statement. Sometimes that is called as one is the we can disable the forever also. So now that we will see in this. Now here example syntax forever, just it is like a only forever, then the statements will come. How will write in the sense forever hash time value. See, if I use like this, what will happen? It will make a block suspend for time value units of time. The time unit can be specified using the time scale command. See, this is the time value. For that time, up to the time value, it will run. For our event expression, you see this, some of the expression I can use it here also. See example, let us say the example using forever. Using the forever, let us use instead of the always block because already used the always block to generate the clock. Now instead of the always block, I can use the forever to generate the clock. Now register clock initial begin clock equal to 0. Up to here it is common only. You might have written your test bench. Till here it is common. Now here I written forever. Forever as 10. If I write it, see this forever will be replaced instead of always block actually. Forever as 10 clock equal to not of clock. So it will be very simple. The clock will be generated. The clock will be generated like this. Then the one more thing important with the period of what? Clock is 0, delay is 10. Means this will be 10, that is also 10. So totally we will have the delay period of 20 units. Now let us say another example. We need to synchronize two register values at every positive edge of the clock. We need to synchronize two register values at every positive edge of the clock. So simple register clock, register X and Y and initialize forever at passage clock. See here, I can use like this also. The passage clock also we can use. For instance, we need to synchronize the both register value at every positive edge of the clock. Means forever at the passage clock X equal to Y. So when you get X equal to Y for every positive edge of the clock, that is forever, X will be is equal to Y. This is nothing but your loop statements. So for the lab actually, so instead of installing the Xilinx in your machine, even you can perform in the online also. without installing the software, you can check your output with the simulation. Even that also you can do. So how we can do that? So that for that, let me say, so what you can use in the sense example, let me show. So in a Google, you go to EDA Playground. There is a website called as EDA Playground. This only. So here, this is the one of the open platform to run your code in online actually. But you need to write both the Verilog code as well as test bench code. Both you need to write, then only it can be explained. So now I will show here how it has to be done. So use the same method, even you'll get the simulation waveform also. Even if you want to log in, you have to register with your official mail ID, or directly you can use it here. See, this is what your test bench place. This place is your test bench place. This will be the right hand side, which is showing this is your, you have to write the code actually. So now what I will do, let me take one of the any examples codes from here only, I will show. Even you can see, actually you can type, or here also you can type, as what you can do, you can create a, already in your system also, you can create a notepad, you can type your program there and save the program in terms of .v file. So even that also can be used here. So now what I will do, let me take a program here, this is the main program here. Just I will upload the file, which I'm having already. For example, I'll show here only. Previous yesterday's program. This is full adder program. Here I will generate your test bench program. Just even you can type also if you want. Just I am uploading the file here. Test bench program also. See now, let's see, it is written. Now what we need to do in the sense, so we have to directly can run the program. So to run the program here, what you will do better, normally I used to say, you can go for the simulators. In this simulator, you can enable the open EP wave. That is a waveform you will get. You can select that. You have to select which kind of simulator is required for you, or compilers. These are the free simulators. These are the commercial simulators actually. You can use anything else, free simulator or compilers, any free anything you can use in this actually. So I will say just I'm going to use The free simulator iCars I'll use. There is a simple one more thing here actually, one additional command we need to run. Why? Because let me run and show for you actually here. See, so if you want to save this, you can save if you want to save, because it will be saved in your login actually. So now what I will do, if you want to run the program, you need to run the test bench only. So I will keep the test bench this side. I will run this. I'm going to run the program, but you can see here we are getting it, but you are getting error here because the reason is what? Because some reason will be the here. What you have to add in the sense simple, I will say just I'll create I'll open the example, let me show, because we need to know, because while doing in the online something extra we need to add actually. The example, let me take the example of a day flip flop which is executed already. See here, which line you have to add in the sense, this is the D flip flop program actually, right? See, I insist you need to dump these two lines. I hope it is clear for you. I'm telling, see this, this is what. See, I'm showing this, which one line is? See, I hope you clear this. See here, this one. These lines you need to use to run your program in your online platform. See here. I hope is it clear for you, right? Dollar dump file dump.vcd dollar dump var s of one. So this has to be done just to dump the variable to s. So it is a D flip flop. See example, what is a D flip flop here? Actually, the program is written in the sense, or if you want to use, even you can use in our program also. So what I will do, let me use this in our program only. If we may get that problem, so I will go for that. I'll open our program which is done. See, I'm not saved with your file name actually. So it will be like today's. You can find out the dates. See, this is what today's date actually told. So I think you can check for the today's. Maybe this only. So here we have to initialize. See, dump variable. I added this. Now let us save this. It will be saved. It will be saved. Now you can run. So if you want, you can change the simulator also. I use the iChorus simulator actually. So this is the simulator which you use. Now here one more thing. This is very little because the test bench is here. You have to ensure it is so many are there. You have to use Verilog. It can be used for any languages also. Then there is no other libraries not required. Only here thing is the tools and simulator. The tools which are using is simulators are free simulators. These are iChorus simulator. This is better I can use. Or GHDL also you can use. iChorus version 9.7 I'll use. So if you want to download the files after running, even you can click this. So let me run the program now. See, the simulation is running. Because we are not getting the waveform over here actually, the result has come here. So I want to say the view, right? So for that, let me choose any other like cadence. I'll choose the cadence actually. Here, which one the tools, simulator, cadence, xcelium, just example. If I use this, let me run. See, the error is no top level. See here, I'm showing the example for 1D because some mistake was there. Just check it. You write your main program in the right hand side. You can see that the example here, the D flip flop is written here. Now here in the left hand side, the test bench is written. The only thing is additionally what you have to do in the sense you need to add the dump waves. This we have to wave the dump file and the dump waves. These things you need to do. So rest all things are no problem actually. As your test bench you can write. So now what you'll do, I selected the tools and simulators are iChorus Verilog 0.7 that I generate. You do only open EP wave after run. Don't click on the download. Now what you'll do, you click on the run actually. Once you click on the run, so you will get the waveform as well as the output wave also. See? Now I'll run. Sometimes it may get blocked over there. See here, it's launching the EP wave. You got the waveform now. See here, we got what are the waveforms for the corresponding things. If you want to save this, you can say you can take a printout of this also. See, you can check your waveforms like this. You can click the corresponding positions. You can check. If you want to get the signals from your test bench, which signal you want to, some of the signals you might have missed out or you may need. So you can take the other signals also. Sometimes which radix we need to see, both hexadecimal, the binary only, it will show actually. Then, so if you want to go marker line, if you want to go, you can use this. If you want to go for scroll right or left, you can use this left and right. So this is the timing is given over there. So like this, you can do for all your programs. If you want to save, you can save this. This waveform also you can save. So this is like this only you need to only simple. You have to do this only. You can run. Even you can use the simulators, which are so many simulators you can try out. So instead of installing your software system, you can do in this way also. You can verify your output.